Good day, everybody. Randy Franklin Smith here. Today we are zeroing in on how to audit logon sessions with the Windows Security Log. Today's webinar and real training for free is made possible by Exabeam. Exabeam is a leading user entity behavior analysis firm, and I've got Andy Scree here from Exabeam, who really, Andy, I guess you probably think about, talk about, and work on this kind of stuff, especially user behavior analysis we're talking about today, all the time. So please jump in and share some commentary where it makes sense, Andy, and thanks again for making today's session possible.
Absolutely, and thanks for having me this morning, Randy.
Okay, so basically what we're talking about is how do you figure out when someone was actually logged on to their PC? Now, the data's there. It's in the security log, but it is so much harder than what you would think. There's really two ways to track logon sessions. One of them requires you to collect events from every workstation out there. In some ways, that's where you get your most quantitative, definite data from in terms of logon sessions, but you have the burden of getting those logs from all the workstations. Or we're also going to look at another way of doing it by analyzing server logon traffic, especially activity about these users gleaned from domain controllers. So stay tuned. It's going to be a fast ride with lots of details. First of all, let's talk about doing this with workstation logs. So this is assuming that you're getting all the logs from all of your workstations out there. You would need to enable both the logon and log-off audit subcategories in order to get the events that I'm going to show you. And folks, don't forget to enable this setting. It's under security options, the force audit subcategories to override the category setting. Because there's two ways to configure auditing in Windows. One is a legacy way with categories. The other is the newer, more modern way with subcategories. And so you want to enable that setting in order to make these changes up here take effect. Okay. So it should be as easy as a logon event and a log-off event and correlating them with the logon ID. And sometimes it is really that easy. So we have two events here. 4624 is a log-on event. 4634 is a log-off event. How do we connect them together? We do that with the logon ID field. So let me show you an example. I'm going to bring up Event Viewer here. And here's let's look for a good logon event. One for an actual user, not from the system. Okay, this is pretty good. So here we've got new logon. This is R. Smith from the lab domain. And look at my logon ID. Let's just remember that it ends in 508. So that's the ID of this particular session. This means I logged on, of course, since it's 4624. What we would want to do is look further up in the log for a logon type 3 with the same logon ID. And this one ended in 508. What we can probably do since it's a log-off event, I'm pretty sure that, since it's a network logon event, I'm pretty sure we'll have seen the log-off event by now because they never last long. And okay, so in this case, we haven't seen the log-off event yet, but that's what we'd be looking for, only the logon ID would match what we found in the logon. So theoretically, that's how you determine a logon session. But things are never that simple, right? First of all, Windows may create multiple logon IDs for something that from the perception of the user is just one logon session. That's especially true with admin accounts. The other thing is sometimes this 4634 doesn't get logged at all. I'll show you cases where that happens. The other thing is sometimes the logon session lasts for days or even weeks at a time. I mean, a lot of us, I don't know about you, Andy, but you know, I never log off from my computer unless I have to. I just let it lock the console. You know what I'm talking about, Andy? I'm sure
Yeah,
you might be the same
100%.
way.
And I probably reboot it once every couple of weeks. My sessions are always lasting days at a time.
Yeah, so we can't treat that as a logon session, right? Because you know, the user isn't there physically present doing work all that time. So how do we determine the periods of time that that logon session is what we would call actually active? I'll show you that as we go along too. The other thing that we'll be throwing around is this term logon type. And I'll show you where that shows up in the event. It shows up in 4624, the logon. Right there under logon information, we've got logon type 3. So if you folks are familiar with the Windows Security Log, if you go to my Security Log Encyclopedia at ultimatewindowssecurity.com, you know, I've got all of these documented. Logon type 3 happens to be a network logon, such as where you're accessing a shared folder on another computer. Oh, and I just realized, Andy, why this logon session 3 has not ended yet, because we are actually looking at a remote event log here, and that was my logon session for Event Viewer connecting to this remote computer here, Lab W1085 that you see right there. And you know, I'm still connected, and Event Viewer is keeping that network logon type 3 session active because it's regularly querying the log, and so that's why we haven't seen the log off event yet. But normally these logon type 3s end very quickly, and logon type 3 sessions are not they're outside the scope of our webinar today. What we're focused on is interactive logons, and that is typically a logon type 2, which I'm sure I can find here just as we're talking. And logon type 2 means you've actually come to the keyboard and screen and logged on. Those are showing up less on Windows 10 because of some kind of funky voodoo is about the best way I could put it, that Windows 10 does when you log on now. And I bet you this is, we're getting close though. And I'll show you that more as we go too. You see more of that, especially when a privileged user logs on, when an admin logs in. All right, so let's see here.
And Randy, I think right here you're highlighting the struggles of many a security analyst trying to go through these event viewers, even if the data exists in a SIM, trying to line up the right logon type, event code, time frame, understand the difference between, you know, when it's a user versus a machine account. It's always a struggle and time consuming to do this work.
Yes, absolutely. And you know, this is my area of specialization. Most of the folks out there can't afford to just specialize in one little area, and it takes me a couple minutes. Here's the one that I was looking for. Here's the test account. I logged on interactively to this Windows 10 workstation, and there you see my logon type 2. That's what we're expecting. And there's my logon ID. We could go forward in time now and look for a 4634 to see if I have logged off yet. A 4634 event with the same hexadecimal logon ID. Okay. The interesting thing is, though, that if you log off and log in again pretty soon, you're going to see a new logon type, and it's going to be logon type 11. If you're a security log nerd like me, you'll know that logon type 11 means that you logged on with cached credentials. Now, Andy, in the past, what that always meant was that it was probably a laptop and you were away from the office and you were logging in and you couldn't, your workstation couldn't find the domain controller, but it says, oh, I know Randy Smith. He's logged on recently before and I have a cache of his credentials. So I'm going to authenticate him locally without going out to the domain controller. But now you see this regularly, even on a Windows 10 computer, actively, perfectly well connected to the domain controller. And I'll explain why that is. So it's gotten more complex, and that's why I've put in here that when an end user, so we're not even talking about an admin yet, so this means least privilege workstations where your end users do not have admin authority. This is the scenario you're going to see. They come in to their computer, they log on, and we're not like unlocking an existing session. We're logging on fresh. You're either going to see logon type 2 or logon type 11. You may, in addition, see a logon type 7, especially if the main logon session is 11. So 2 is an interactive logon, 11 is interactive but with cached credentials, 7 means that the workstation was unlocked. So here's the scenario, folks. When you first turn on a computer, and let's say you've booted it up fresh and you're logging on as Randy, or you're logging on to a computer that's maybe been up for a while, but it's the first time this particular user has ever logged in to a Windows 10 workstation, then you will definitely see logon type 2 as the first logon type for that user. But if within a relatively short period of time you log out, log back in, Windows is going to say, you know what, I still have a Kerberos ticket granting ticket for Randy Smith or for Andy Scree. And instead of going out and bugging the domain controller again, I'm just going to reuse that ticket and I'm going to log it differently. I'm going to log this as a cache credential session, and something that they always do under the, under the hood is they treat it as though you're unlocking the workstation, and that is what generates a logon type 7. Okay, so I know this is probably getting confusing, but that is just the reality of how Windows 10 nowadays handles logins, and it gets even more complicated when we move to an admin logon. So what do you need to do? What you can do, first of all, is just ignore logon events where the logon type is 7. For the analysis that we're talking about, for determining, for recognizing logon sessions, we can ignore 4624 when we see logon type 7, number 1. Number 2, nowadays on Windows 10, I would just interpret logon type 2 or 11 as the same thing. It's an interactive logon at the local console of the computer. And what you want to grab out of that is the logon session ID and correlate that later in time to the log off event, 4634. Let's see here. Ralph says, is there still value in collecting log off events since the users do not always truly log off? There is, Ralph, because other things happen that tell you that the user wasn't present, namely the workstation locks. You have a password protected screensaver. There are events logged when those kick in and when those are deactivated. So I'll get to that in just a couple slides. Ken says, isn't logon type 10 also interactive via RDP? So yes, remote desktop would be included in here if you're tracking remote sessions. What I'm focusing on today is just your typical workstation where a user is physically present. Okay. Ryan says, what's the difference between 46, Ryan, you said 4634. I think you mean 46, you say 4636. I think you mean 4634. And 4647, you've been using 4647. So 4634 is that a logon session actually ended. Prior to that, if the end user says, hey, I want to log out, Windows will log at 4647 saying user initiated log off. But that is just saying the user requested it. There's other things that can cause that session to log out. And so it's better in my opinion to go with 4634 because it covers both bases, whether the end user himself initiated the logout or whether the system logged them off because the system was shutting down. Okay, Ryan? So that's why you would go with 4634. Okay, now that's the basic scenario. Let's talk about what events. Let's skip the next slide for a second. I want to come back to admin logons, but let's just say we're still talking about an end user who's not an admin on their workstation. They log on, so we get a 4624 of either type 2 or type 11. Now, let's say they remain logged on until they need to go to a meeting. And let's say they're a very security conscious user. And before they go to the meeting, they lock their workstation. You know, there's different ways you can do that. You can press Control-Alt-Delete and click lock, for instance. So what do we get? We get a 4800. If you look in my security log encyclopedia, 4800 means that the workstation was locked. Let me just show you an example of that real quick.
And I would bet in many organizations you're going to see more 4800s than the actual log-off events. Yeah,
oh, absolutely. Assuming that users just walk away from their computer and let it lock up, or they lock it, that's what you're going to see. Right here, 4800, the workstation was locked, and you see it gives us the username, but it also gives us the logon ID. So that's the same logon session ID that we were talking about before. Just ignore this session ID down here. That has something to do with the GUI. It's not useful to us. We're interested in the logon ID. Okay, so the users walked away from the computer, they locked it, or let's say the user walks away and just allows the password protected screensaver to kick in. You're going to get two events then. You're going to get the same 4800 we talked about, that the workstation was locked. In this case, it just happened automatically as opposed to the user doing it themselves. How do we know that? Because in close proximity, we see a 4802. And guess what 4802 is? The screensaver was invoked. Okay, so in close proximity then, if I clear the filter, then we would see a, both the workstation lock and the screensaver kicking in at the same time. This is how I want to do it. Yeah, there you go. So screensaver was invoked for Berry Vista, and the workstation was locked. And let's see here. The session ID matches. There you go. The logon ID 3C41E, 3C41E. So in this case, this tells us that Barry just backed away from the keyboard and mouse and let the workstation lock itself. And the reason we know that, the reason we know he didn't initiate it himself and lock the workstation is that the screensaver was invoked at the same time, if that matters to you. Okay.
Yeah, and it's some organizations that can be important, right? That could be against policy to walk away from your workstation and not lock it. So this could be a good way to kind of enforce security awareness and train these users that are potentially doing risky behaviors.
That's a good point. I like that. Okay, now, what if the computer goes to sleep? What if the workstation screensaver hasn't kicked in? You know, what happens? Well, it logs a 4800. So when the workstation goes to sleep, it locks the session right before it goes into a quasi-shutdown state. And you know, you're not going to see any more events until the system wakes up. So the user comes back and either wakes up the computer and you know, or unlocks their workstation. You're going to see a 4801. So let's add that to our filter here. And there's a 4801. The workstation was unlocked, AD test, and again, you've got your logon ID. So you see, the logon ID is really important for correlating, linking these events over time to see the continuity of what's happened at this workstation during this extended logon session. And you see, from that, then we can create a timeline of knowing when the user was apparently physically present and actively working and when they weren't. Hey, what if the power just gets interrupted? So the computer, it's like, you know, pulling the plug on a desktop computer or pulling the battery out of a laptop that's on battery power. Okay, then you're going to get an orphaned logon event on Windows 10. For what it's worth, there was a time in Windows when Windows attempted to artificially log what I would call synthetic log-off events for interrupted sessions when the computer came back up. I don't know if you've ever seen that, Andy, but I don't remember now if it was XP or Windows 7, but I remember seeing one time log-off events occurring immediately after system startup, and the logon ID matched a logon event, a log-on event that occurred before the system was started. So, you know, Windows was keeping it, you know, on disk somewhere, the logon IDs that were active when the power was shut down. But I do not observe this now in Windows 10. What if you shut Windows down and there's a logon session active? Then that log-off, that logon session will get logged off. There will be a 4634. And that, Ryan, is why, again, I recommend you use 4634 instead of the 4647 event, because I don't think you'll see a 4647 in that case. Stefan asks, what is the logon event ID for Windows 7? It hasn't changed. It's 4624. And for what it's worth, folks, my Windows Security Log Encyclopedia documents all of that. For every operating system, you know, what is the event ID, what changes between each operating system, and so on. Okay, now, we've been limiting our discussion to non-admin users of workstations. Let's go and now say what's different, because I bet a lot of folks out there, Andy, have end users that have admin authority to their workstation. That is still fairly common. You know what I'm saying?
Yeah, absolutely. Local admin is pretty frequent out there from what I've seen.
Especially technical users, power users, and so on, consultants. So here's what it looks like then. This is really funky. And it all has to do with user account control. You know, when you try to do something that requires admin authority and Windows throws up a special dialog box saying, hey, this requires admin authority, do you want to allow this? How is it doing that? Well, when you log on to Windows 10, assuming that user account control is activated, is enabled, and when Windows sees that, oh, you're a member of local admins, then what Windows actually does is it creates two logon sessions for you. One with admin authority, one without admin authority. And everything that you do normally as just an everyday user, everything you start from the start menu that does not require admin authority, takes place in the non-privileged logon session. But as soon as you do something that requires elevated authority, Windows switches over to that other logon session that it created at the same time when the user actually logged in, and executes that particular action under the other elevated logon session. So what does that mean? It looks really weird in the log when a local admin logs on. You're going to see 3 instances of 4624, that is the logon event, in rapid succession. You're going to see a logon type 7, which means workstation unlocked, and an immediate log off for that one. But remember I said, for our purposes, we can pretty much ignore those. But this is what you'll see in the log. So 4624, Randy Smith, logon type 7, and then immediately a 4634 for that same logon ID. So that is just where Windows in the GUI accepted your credentials and verified that they were correct. Then it creates 2 additional login sessions that are persistent in this case. They stay open. And the only difference between them, they're both, 4624 for Randy Smith. They're both logon type 11 cache credentials, but the only difference is one of them will say elevated token yes, the other will say elevated token no. Now both of those logon sessions go on living. And by the way, they are linked to each other. You'll notice I've called that out right here in the bullet point. Let's show you an example. This time we'll look for R. Smith because R. Smith has admin authority. And we don't want to log on type 3. There we go. This is getting closer to what we want. Okay, so look at that. R. Smith logged in. You can take it on faith. He's a member of local admins. Log on type 11. Elevated token yes. And if I'm not talking through my hat, the very next one will be for R. Smith again. Log on type 11. Elevated token no. Now, how do I know these 2 go together other than their close proximity in the log and that one's elevated and one's not? Well, look at the logon ID and the linked logon ID. So this is logon ID 181 with a linked logon of 172. Now watch closely what happens when I select this one right below it. The very same numbers, but you see how they're reversed, Andy? So this is saying these 2 logon IDs are like, twins. It's just one is elevated and one's not.
Yeah, absolutely. So it makes it very important when you're doing an investigation here to understand both of these IDs and make sure that they're in your query if you're querying this in a SIM, to make sure you're not missing either the elevated or the non-elevated activities.
Yes, and that is interesting too, because the elevated activities are going to take place in this logon session 172, since it's the one that's elevated. Yet, this is interesting, the events of the workstation being locked and unlocked, the screensaver kicking in and kicking out, are all going to be logged on this session, the unprivileged one, 181, down here. Mike says, what's the logon ID of the logon type 7? It doesn't matter because it's immediately terminated with a 4634 log off, and you don't see that logon ID anymore. So it just doesn't matter, Mike. Okay, so that keeps it pretty interesting. AJ says, my understanding is logon ID is the time between reboots. Does that mean multiple users will have the same logon ID and a user could log on and off multiple times under the same logon ID? No, it's not impossible in a given security log for a given computer to see the logon ID session number repeated, but that's just because it wrapped that range of numbers. But as you can see, that's a very large hexadecimal number. So you can, just like we don't worry about hashes colliding in our problem space, you can pretty much not worry about logon IDs repeating too. Okay. Chang asks, as Windows 10 now reports events differently than previous versions due to funky voodoo, does that mean that broad multi-workstation SIM queries should also include a Windows version check to accurately understand what's happening? Yeah, that's one of the things that makes security log analysis difficult, is things that change from one version to another. And you try your best to limit that with queries that can ignore those changes. But you do have to take it into account sometimes. Surinder asks, do all these event IDs get pushed to the domain controllers? No, absolutely not. I'm amazed that misconception still persists. Every Windows computer out there has its own unique security log, and there's no activity replicated between them. Even on domain controllers, if you have 5 domain controllers in one domain, then your overall domain audit log is fractured or split up between those, fragmented between those 5 different domain controllers. So even domain controllers don't replicate their events.
And Randy, I hear that question all the time when customers of mine want to look at who's potentially RDPing to other workstations around the environment, but they're not collecting the logs on the workstation. And therefore, you don't see those 4624s log on type 10. You're not going to get that from the DC. All you're going to see are those network authentications. And so it's really important to if you can, collect these events because they provide so much visibility.
Oh, yeah, exactly. Basically, any computer you don't collect events from, there's a blind spot that's created in your visibility. Oh, hey, Ali asked, what is logon ID 3E7? Okay, so folks, on this particular event, 4624, just ignore the subject information. It's always system, the name of the computer, and the logon ID is always 3E7. That is a hard-coded logon ID for the operating system itself, okay? And subject is usually important in Windows events, but it is unimportant on 4624. You want to start reading from this point down on logon events. Amna, should we be collecting from all work servers and workstations? Yes, absolutely. That's I've been preaching that for years now. Andy, if we want to catch today's types of attacks, we need to think about where they begin. They begin on the workstation. APTs begin with a drive-by download or a phishing email that targets some end user that is not even the ultimate target of the bad guy, right? Like, I mean, the very first time we heard the term APT with RSA, that was an attack. It all started with some user in HR who didn't have access in any way, shape, or form to the seed numbers that they were actually looking for and ultimately obtained.
Yeah, absolutely. I mean, when we look at the Verizon data breach report and all these reports that are being put out, and you look at how many of the complex and large attacks start with phishing, right? That's happening on the endpoint. Someone clicks a link, drive-by download, malware. Then you start to see lateral movement, which you can catch using just domain control authentication. But when you see things like lateral movement, you need to figure out, well, what spawned this? And you always have to go back to the endpoint.
Yeah. Ryan says, since logon type 11 is cached interactive and admin login, how do you tell a difference? So logon type 11 just means that it's a cached interactive. It doesn't mean that it's admin. Here's what means that it's admin. When you see elevated token, yes, that's what means that the user's an admin.
And you should also,
Okay.
can you get that from the security ID as well, looking at the machine versus the domain that's being authenticated? So it's lab rsmith.
Well, if you knew that rsmith is an admin, sure, right?
Okay.
All right, let's see here. So let's see here. We're going to move on. Folks, there's a lot of questions here that are outside the scope of what we're talking about today. I'll do my best to answer them a little bit later by text, and I'll share the answers with everybody. So let's forge ahead. Let's see here. I've talked about all the events that occur that are relevant to the logon session in between log on and log off, which could be separated by weeks. So we've talked about those. All right, so then how do you analyze logon sessions? Well, it requires that we, if we're going to do it this way, that we collect logon events from all computers, including workstations. We want to count the session as beginning when you see 4624 with either logon type 2 or 11. Then count the user as not present between 4802 and 4803 if you're going by screensaver, or between 4800 and 4801 if you're going with the console being locked. Count the session as ending when you see any of the following: a 4647 for the same logon ID, a 4634 for the same logon ID, or a 4608 that the system started up, right? Because if obviously the logon session ended when the computer went down. It really helps folks to understand the difference between authentication events and logon events. And by the way, the only events we've been talking about so far are logon events. When we get into Kerberos and credential validation NTLM events, that's when we're talking about authentication, so stay tuned on that. Understand that certain mythical logon sessions don't exist, and by that I mean with domain controllers. Domain controllers, Andy, Windows gives the impression that you're logging into the domain when you log onto your workstation, and I used to always hear the term, "Are you logged into the domain?" And that just doesn't happen. There is no log on to a domain. You log onto your workstation with a domain account. The domain controller authenticates you, but it doesn't keep track of the fact that you are logged on somewhere, and it doesn't keep track of when you log out. It just is a point in time. Yes, I authenticated Randy Smith. So the only way to get the session is either come at it directly, indirectly, which I'm going to show you next, or go to the source of each computer where you were potentially logged on.
Yeah, I think that is a very common misconception, and a lot of organizations don't realize that in the challenge until they have an incident and they have to go and do this kind of forensic investigation and understand the challenges that Windows actually has inherent with the logging.
Yeah, and that's why there's no place that you can go in Windows and just, like people would think, oh, you should be able to go to the domain controller and see where is Bob logged in, what computer is he logged on at. There's no central body keeping track of that unless you buy some specialized third-party software. The other thing is the difference between an active logon session and the periods of time when that session is on hold, when the screensaver is invoked or the computer's asleep. Remember that logon sessions can be associated with domain accounts, but they can also be associated with local accounts on that computer. Got to collect events from all these computers. Takes a lot of correlation. And of course, the other question, Andy, is, all right, so now we know Bob was logged on. He was actively at his computer between 8 and 10:10 p.m., right? But what was he doing while he was there, right? That's a whole nother story, right?
Yeah, exactly. And not just what he was doing, but how does that relate to what is normal for Bob on that machine at that time?
Yeah, that's great. Okay, now let's jump on a different track and let's look at a whole different way to, I guess, more indirectly determine logon sessions, and that's with server logs. And by servers, I mean both domain controllers and member servers. So let's start with domain controllers and what you get there. When a user logs on and unlocks their workstation, here's what happens. the workstation checks in with the domain controller. So it's relatively easy by looking at your domain controller to determine the beginning of a logon session. But as I was just saying, there's no such thing as a domain logon session. So domain controllers know that you are out there, or you were out there at least, and that you logged on to some computer because they told that computer, yeah, he's authentic. But they don't keep track of you after that. There's no concept on the domain controller of your logon session to this amorphous thing called the domain. So what domain controllers log are authentication events, not logon sessions. And what's the difference in the security log? There's logon events, and then there are account logon events. That's a different category in the event log. Let's go to a domain controller event log, and I'll show you what I mean real quick. So I'll ask it for 4768, I think is a good one. Okay, so here you see 4768 is Kerberos Authentication Service, and if you go and look at the category above that, it's called Account Logon in your audit policy, as opposed to logon. So what's the difference between account logon and logon? It's horrible terminology, very confusing. But logon, logoff means logon sessions. Account logon should have been named authentication events, and it would be so much clearer. By the way, folks, if you want more background just on the overall security log and what all of these audit policies are and whatnot, my entire Security Log Secrets course is available free at Ultimate Windows Security. So some of you are obviously coming in with a little bit less background, and I would highly recommend you check out. The course is free, and it's something like 12 CPE credits. But it'll give you some valuable background for the concepts we're talking about here today. Let's see here. Okay, now, so here's the thing. So by that, do we mean that, wow, it's useless, then you can't track logon sessions from domain controllers? Well, not so fast. In fact, that kind of used to be my stand, Andy, until you brought us this topic and, just describe to me the technique that you guys are doing from taking what I would call a more indirect analytical approach by just looking at the activity on the domain controller. So Andy, tell me if you agree with this. The way I put it is, but while a user is logged on and actively using their workstation, they generate activity in domain controller security logs and parenthetically other member servers, which, in the absence of which, you can deduce the user was absent. And so in the presence of that activity, you can deduce the user was present, and then, as I say, put brackets around that and say this is a logon session. So Andy, augment that or edit it as you like.
Yeah, that's correct. And this is kind of one of the underlying technologies that we've built from an analytics perspective, right? It's very difficult, and you wouldn't want to do this as a one-off, but allowing the machines to understand these logging events, logon types, whether it's domain controller coming from the local workstation, and building out what we call at Exabeam sessions, which is really when the user's active on the domain and logged into a workstation. 90% of the customers I talk to are not collecting the workstation logs. And so by leveraging these Kerberos 4768s and even the NTLM's 4776 events, we can get very accurate in terms of when a user is actually logging into their workstation, purely just by looking at these domain controller authentication events.
Yeah, and we're going to do that by primarily looking at authentication protocol events from Kerberos and NTLM, but we'll also look at some other stuff too. So Kerberos is authentication. There's no concept of a logon session with Kerberos. The way it works is you initially get a ticket to the domain controller. So when Bob comes in, logs on first thing in the morning to a computer that just booted up, then that workstation goes out to the domain controller, says, is this really Bob? If it is, give me a ticket granting ticket. Then Bob's workstation uses that TGT to in turn request service tickets to every computer that Bob tries to access, including the workstation itself. And what you get in the security log is events whenever these service tickets are requested. Now, if the user or the computer remains up and the logon session remains active, then tickets can also be renewed, and so you'll see events for that. But all of this generates events in the domain controller security log. And here are some of the events. Now, I'm not going to go through each one of these events because of this point right here. The Kerberos protocol is very in-depth. There's a healthy degree of complexity with it. And exactly how it's used by Windows is an in-depth subject, which I do cover in other webinars. But for the purposes of logon session auditing, it's actually pretty simple. It's basically a matter of recognizing periods of activity and periods of quiet for a given user. Andy, you want to add anything to that or beg to differ?
No, I 100% agree with that. You know, when you look at, especially if you're collecting these events in a SIM or centrally, and you look at 4768 for a particular user from all your domain controllers, there's going to be a lot of events there. And so identifying those areas of quiet and when they're active can help narrow down the scope of when they're actually logged in. But it takes a little bit of analytics on top of that to be very accurate.
Right. And let's see. By the way, one thing to know is Kerberos events always identify the user account, the client, or that's typically going to be the workstation, and the server they're connecting to. Now that may be by the Windows, by the Active Directory name of the computer, or sometimes, like in the case of the client, it's the IP address. Now, you will also see NTLM events. They're called credential validation, but they mean NTLM. And whereas Kerberos authenticates a client to a server without the domain controller and the server ever communicating with each other, that's with tickets. NTLM is a pass-through authentication protocol, so that changes a little bit the information that you get in the event. But it remains that there's no concept of a session. So what happens is the client goes to the server, requests a login. The server says, oh, these credentials are domain credentials. So the server does communicate with the domain controller in that case and passes those credentials to the DC. The DC says, yes, he's authentic. And it's at that point that the DC logs a credential validation request, which tells you that that user authenticated to some computer somewhere on the network with NTLM. But the one thing with NTLM events is they don't tell you the server that the user is connected to. They just tell you the user and the NetBIOS name of the workstation. But for our purposes of figuring out logon sessions, it works pretty good. Now here's one other type of activity that you get on domain controllers. And I don't know if you use it, Andy, but whenever a user logs in, and then approximately every 90 minutes afterwards, that workstation goes out to the domain controller, logs onto the domain controller with a network type 3 logon session to refresh group policy for that user. And so this shows up on the domain controller as a 4624 logon type 3. And it's just there because it's refreshing group policy. But the cool thing is it tells us that the user's still there. If the user isn't at their workstation, the workstation goes to sleep, then that doesn't happen.
Yeah, we use those kinds of events to what we call extend sessions, to continue and say this user does have presence as it logged in. When we stop seeing those, we'll look for a period of inactivity, then time it out and close that session and say, even if we don't have the the workstation locked, we're not seeing these 4624 logon type 3. The user's no longer there. Let's end it, and we'll wait again when the user comes back in the morning or later in the afternoon.
Cool. Now, if you also are getting events from member servers, they can be useful too. Servers don't really keep track of logon sessions for end users either. Like if you're accessing shared folders, files on a shared folder, as soon as you close any file you have open on that share, your logon session ends. So in a file server, the security log makes it look like the user logged in and out like a million times in a day. SharePoint, if you look at the SharePoint audit log, there is no log on log off event. But in the Windows security log, you will see log on events of either type 3 or type A when the browser authenticates to the SharePoint site. But again, there's no real log off event per se, because web applications are strange in how they work that way. But anytime we see activity for a user, we know that they're active, they're doing some work, and so we extend that logon session. And the same thing can go with Exchange. I wouldn't mess with the mailbox audit log, but again, on the Exchange servers, the Windows log will show logon events of type 3 or 8 when the mail client is checking in. Now, if that is some device out on the internet, you may not want to include those, right, in order to determine a physical logon session at their desk. And the whole thing is, if a user walks away and their PC sleeps, then that activity stops. So it's basically a matter of putting brackets around events in close time proximity until they time out and declaring those sessions. So the bottom line is, if you go the workstation route, you're going to have to collect logs from many more systems. That's far more log management resources. If your SIM charges by EPS, events per second, or gigabytes per day, we're talking about exponential changes there. And of course, it requires some pretty sophisticated correlation. Using server logs, we get logs from a lot fewer systems. Of course, there's going to be less resources. It's less quantitative, but it's qualitatively sufficient. And we're basically just correlating by user and time. And let's see a practical applied application of this. I'm going to turn things over to you, Andy, and show us how you guys do it at Exabeam.
Absolutely. Go ahead and share my Chrome browser here.
We can see your screen.
Okay, excellent. And I'm going to start in the Exabeam Data Lake product. So Exabeam has been shipping what we call our advanced analytics, or our UEBA product, for over 3 years now. We're the #1 market leader in that space. But last year at RSA, we actually unveiled 2 new products that complete what we call our security intelligence platform. It's really a next-gen SIM. And it all starts with data collection. And we have a product called Exabeam Data Lake that's built on open source Elastic, right? So we know that it scales. And we chose this open source technology so we could change the pricing model of how we sell this. We're not charging based on volume or EPS or gigabytes per day. We're allowing our customers one flat fixed price to log as much data as they want. So 1 gigabyte or 1 petabyte, it's the same price. This is now should allow our customers to start to look at, maybe I can start to log my workstation event. Most customers I talk to don't have that level of granularity. But I wanted to start in the data lake here just to kind of look at how I used to do this kind of activity. So before my job here at Exabeam, I was actually a lead security engineer at eBay, and I helped build their SOC. And I struggled with this challenge of Windows logs. We collected the domain controller authentications, but it's very hard to get the value out of the events. And I constantly had to go, Randy, to your encyclopedia to figure out logon codes or logon types and event codes, and it was a struggle. This is how I would go about potentially doing it with just a SIM or a search platform, is I would look at those 4768 Kerberos events. And one of the things you're going to see here in Exabeam's Data Lake is we have this enhanced view, which already starts to pull out the relevant bits of the Windows event code that a security analyst would care about. So instead of looking at the raw data, like you would in most SIMs, where I have no idea if this is a failed or successful login, we provide this enhanced view to give you that visibility up front. But if I scroll down and I find a successful authentication here for this particular user, As we had mentioned, this is essentially the client address. We're parsing this out as the desk IP. Now, if I want to figure out, did this user come and log in to their computer in the office, I would first have to take this desk IP and figure out what kind of host is it. Because 99% of the time when you have user population logging in the office, they're logging into their workstation. So I need to first start figuring out what host had this IP right before this event occurred, and then I'm going to get a host name. And then I need to figure out, is that host a workstation or a server? Maybe I can figure it out based on naming conventions. Maybe I have an asset database, but in some cases I don't have either. And this is the real challenge, is to try and go through potentially, hundreds of these 46 or 4768 events against different IP addresses and figure out which one is the workstation that should help me start my session. Right? And so this was the challenge we set to solve with the Advanced Analytics product. So I'm going to pivot over into the Exabeam Advanced Analytics here. This is kind of the main dashboard that you get when you log into the UI. Now, what Exabeam Advanced Analytics is doing under the hood is we're basically building user sessions. And as we had talked about today, a lot of this is going to be based off Windows authentication. We're going to leverage those NTLM and Kerberos authentication events to start a session when a user logs in. Then we're going to track everything that they do throughout the day. That's going to be access to other servers. This could be file activity, proxy activity, application activities, endpoint process execution. We can see everything that these credentials and users do. We'll start to baseline their behavior to learn what is normal and then start to identify anomalous behavior. So let's take a look at one of these users and how we're building these sessions using Windows domain controller authentication, because this is what most of my customers have. We're going to start by looking at Barbara, who's got a really high risk score, and she's a notable user, meaning she's been deviating from her baseline and doing a bunch of anomalous activity, and we're scoring her with 222 points of risk. So I'm going to go ahead and click on her. The first thing we're going to see is this information card. This is context that we're pulling out of Active Directory or some sort of HR system. This is all important to get an understanding of who Barbara is in the organization. So Barbara is a human resources coordinator. Just having this little bit of information can start to inform the investigation that I'm about to perform here. I can start to think about the things I know Barbara should and should not do on the network. Like I wouldn't expect Barbara to log into my domain controller interactively or via RDP. Those are the kinds of things that are important with this little bit of context. We can also see things like her contact information here if I need to reach out to her to validate some of the activities that I'm seeing. We have her manager and her manager's contact info. So maybe it's more of an insider threat type scenario. Might want to reach out to Barbara's manager directly. And then we're also going to show you Barbara's peers. Right? So this is an important concept of not just looking at what's normal for Barbara, but what is also normal for her peer groups. And in this case, we're using different Active Directory attributes like her department or her title. But we can also dynamically understand peers based on her activity. Like what applications does she use? She logs into TriNet. So if I look at one of these particular peer groups, we can look at all of the other members of the peer group. What is their membership relationship here? How strong or cohesive are these users? Should they be performing similar activities? And we'll also see their latest risk score. So as I scroll through here, this not only tells me who's Barbara's peers, but also can give me context. I'm seeing most of Barbara's peers with 0 risk scores, and Barbara's got a really high risk score at 222. So clearly Barbara's doing something that's out of the norm for her. Now, if we look below the information card, we have Barbara's risk timeline. I'm going to expand this out to a month. Now, each dot on here represents essentially a session for Barbara, from the time she logged in to the time she logged out. Now, for most users, these are going to be based on those Windows authentication events we just spoke of. In some cases, they could be VPN authentication events, or even access to a cloud application where there is no domain authentication occurring. But in the purpose of Barbara here, we can see that she's logging in Tuesday, Wednesday, Thursday, Friday, about at the same time, 7:53 a.m. She's not active on the weekend, and she comes back on Monday. And we see all of these login sessions for Barbara. We can see things like how many different events made up the session, how many accounts did Barbara use? Did she just use her V. Salazar account, or is she leveraging administrative credentials? How many different assets did she access? And how many network zones or segments did her credential become active in? And what is her overall risk score? So we can see here that Barbara looked pretty normal. She had 0 points of risk, which ties directly into what we saw with her HR peers. But all of a sudden, on Wednesday the 27th, the risk starts to increase, and here's where she scores 50 points. What I'm going to do is I'm going to click on this dot, and we're going to drill in to go to View Timeline. And this view is completely unique to Exabeam. This is what we call our session timeline. And this was really the reason I bought the Exabeam solution when I was working at eBay, was to be able to have timelines like this for investigations. This is what a security analyst is doing when they're investigating a piece of malware or some other alert, is they're trying to figure out what did the user do on that day? What happened before the malware? What happened after? And it's a tedious thing to go through the event viewer and build these things manually. What Exabeam's doing is building these sessions for every user on the network every single day. We have a lot of customers that, the SOC guys are always trying to avoid talking to HR, because HR is always coming to them and saying, I need to know what this user did the last 2 weeks. It's a very painful process to comb through the SIM to gather that information. Exabeam is building these timelines automatically. So in the case of Barbara, what do we see? Well, Barbara starts her session at 9:26 a.m. And this is a Kerberos login event. So here we can see the time. We have the user credential, the destination host, or this is the client that she's logging into, and this is being reported off of our domain controller. So these are those Kerberos logins being reported off the domain controller. Now what Exabeam is doing here is it's looking for this Kerberos login for Barbara where we had no activity before. So her session from the day before had ended on Tuesday, so Barbara was essentially logged off. Then we see this new Kerberos authentication come in for Barbara. And we don't just start a session for any Kerberos authentication. What we're doing is we're looking at the destination IP address. And we're saying, is this destination IP or guest host a workstation or not? And so as part of this session tracking technology, Exabeam builds this host to IP mapping at any given time. So we'll use actually the Windows event codes where DHCP logs are not available. And we'll start to map host to IP addresses. But we take it a step further and we start to assign presence of a user on that host, which allows us to essentially do username to IP address attribution on the fly. And so here what we're doing is we're saying, I have a Kerberos authentication coming off the domain controller. This dest IP is actually tied to this workstation, this host. And Exabeam knows this host to be a workstation. Now, how does Exabeam know this? Well, two different ways. One is you can provide this information to Exabeam through either LDAP if you have your host defined in Active Directory or a CMDB. But in a lot of cases, that's not all that accurate. So Exabeam's developed a machine learning algorithm that goes out and it classifies hosts across the environment based on behavior. We look at attributes like how many users log into this host. If it's a high number of users, it's more likely a server. We'll look at things like, does it have a static or a dynamic IP address? And servers are going to have static IPs. We'll look at the relationship of other assets in the same subnet. If I know that 9 out of 10 servers in this, or 9 out of 10 systems in this subnet are servers, then this 10th one in the same subnet is most likely a server. So we have this machine learning, again, to help make these kinds of sessions accurate based on the domain controller logins themselves. So Barbara logs in to this asset. Now, based on the naming convention, I can also pretty clearly tell that this is probably Barbara's workstation. But what Exabeam also does is it models who logs into these assets. So I can actually see the top users Barbara Salazar. I can look at all other users who have logged into this machine before. What Exabeam is going to do is it's going to assign ownership of the top user to that asset. So where I don't have a CMDB or I'm missing asset information, a lot of my customers use the solution when they get a host to figure out who owns it. Not only to figure out what is it doing on the network, but now I might have a contact to reach out to identify more information about that asset. So once Barbara logs in with this Kerberos login, then we start to see remote access events. And here she's authenticating off of what looks like an app server. Now again, these are coming off the domain controller, or actually here this is coming off the local workstation, that Chicago app server. So this is one of those member servers, and we know this because it's a 4624, which means this is logged locally, and it's that network logon. So it's not an interactive login. Barbara's just accessing this server. Now, what you're going to notice here is there's no sort of anomaly or risk assigned to this particular activity, which means this is normal behavior for Barbara. Then we see her log into an HRMS system. She actually performs different activities. She's viewing employee performance records. And then at 10:45 a.m., she receives an email from KLEnergy.com. This is the first email to her from this particular domain across the entire organization. And if I look at this particular domain, I can see that the top domain is KT Energy, which is Barbara's organization. So this one looks similar, but it's KL. If we expand this event, we can see that Barbara received an email that let her know that her paycheck was ready, and it included a zip file. Now, even though Barbara just had her phishing awareness training, she's excited that her paycheck is ready. She clicks on that link, and now all of a sudden Checkpoint's alerting us that Barbara's hitting a malicious URL. A little while later here, again, we're seeing more remote access activities. So we're seeing Barbara hitting file servers here, and again, that Chicago app server. We see now Barbara's got malware on her machine, another Checkpoint alert. And then we see a few more remote access events and some application activities. And then what essentially is happening here, after these last application activities at 3:42, we're no longer seeing Barbara's credential authenticating off those domain controllers and member servers. Therefore, by default, Exabeam waits for 5 hours of inactivity and times the session out and closes it. So you can see this was Barbara's session in her workday for Wednesday. Now, what happens on Thursday after she got phished and got malware, we see all of a sudden her credential VPNs in from the Ukraine. Now, this is another way outside of Windows to start sessions. And when we see this authentication from the Ukraine, we're calling out the fact that Barbara's never performed any activity from the Ukraine before. This is a statistical anomaly, and we score that with 20 points of risk. Now, as an analyst, this is great anomaly detection. But what I want to know is, well, where does Barbara normally connect from? Well, I can go ahead and click on the Ukraine and expand this and expose the data model that Exabeam has built on the back end. And we can see that Barbara's only ever connected from the US before, never from the Ukraine. We also know because it's the first time from the Ukraine, it's the first time on this ISP. It's also the first time we've seen Barbara from this particular device, CC559. We're transferring some risk from the past session, right? Because Barbara had elevated risk the day before and looks like she was phished, we're going to take the 50 points of risk and we're going to transfer a portion of this risk into our next day. And this allows us to catch those more low and slow attacks across the network. Barbara's logging in on the VPN at an abnormal time, 2:04 a.m. It's also the first time we've ever seen this device, CC559, being used across your organization. This, again, is a small piece of context that's important because it's not like this machine was refurbed or refreshed. Someone else had it and now Barbara does. No one ever has used this device to connect to the network before. And obviously, we have the first source IP address. So now Barbara, who looks like she's phished, is coming in from an abnormal country. Most likely now this is actually not Barbara, but someone leveraging her credentials. We again see 7 remote access events. These are coming off of various member servers across the organization. Barbara's authenticating to all of these different resources. This is very common to see a lot of remote access events or these 4624 Logon type 3 shortly after the domain authentication, right? Map drives are being spun up and file servers that are being mapped. So you're going to see all of these access events occur very quickly. But starting at 2:13 all the way to 2:15, we start to see what looks like lateral movement across the environment. And I saw one question pop up. One of the users asked, could we use 4624 to detect lateral movement? And you absolutely can. Right? What Exabeam is doing is we're looking at all of the remote access, 4624 Logon type 3, we call these remote access, and we're looking at when a user's accessing systems for the first time or abnormally. That's typically where we're going to see lateral movement. Users are going to access new resources, and they're going to access a high volume of resources in a very short amount of time. So here, within 1 or 2 minutes here, we see all of these remote access events. A lot of these are first time she's accessed this particular system. And again, I can open up this server, what looks like a server, and look at the top user in the department. So why is Barbara in HR now accessing a system for the first time where the top group is IT? And IT is the only one that's ever accessed it. Barbara's in HR. I can also look from Barbara's perspective and see that she's never accessed this particular asset, but these are all of the assets that she's remotely accessed before. You're going to see a lot of domain controllers in here and app servers and file servers. That's part of her job. We scroll down a little bit further, and then all of a sudden at 2:14 we see a remote logon. Now, a remote logon for Exabeam is a remote interactive login. This is going to be an RDP or an SSH. So as remote access, we can't determine whether or not they're always interactive or not based on where we're getting the events. But here we can actually see that my Colo SysDB is telling me this is Logon type 10 remote interactive. And what you're going to notice here is this first remote logon gets scored much higher than a first remote access, because here we know this is an interactive login occurring for Barbara. Now, once she's RDP'd into my ColoSysDB, what Barbara decides to do is escalate privileges. And this is coming from the Windows 4648. And again, this is a local event. So if you're only logging domain controllers, you're only ever going to see that right-click run as on the domain controller. Here we're getting it from the ColoSysDB, so we can actually see Barbara escalating her privileges to my system admin account on this server. Exabeam's letting you know that Barbara's now using a privileged account, SA. It's also the first time we've ever seen Barbara switch to this particular credential. So we've seen Barbara leverage HR shared before, but never system admin. Now, once she's got my system admin credential on my ColoSysDB, now she can kind of leapfrog from my ColoSysDB and log into my SQL server. Right? So we see another remote login, interactive login, logon type 10. Once she's on the SQL server, she goes ahead and logs into the database. The first time anyone in HR has ever logged into or accessed this database, as well as the first time for Barbara. We see her perform a couple database queries. She's going to select all from payroll employees and do a drop table backup. And then now all of a sudden our Palo Alto is alerting us to large outbound traffic volumes. Right? So we have 5 gigs going outbound, which is our database. So when you think about this, and you think about how much time it would just take to kind of put the bounds around beginning and end of these sessions, and we hadn't even talked about VPN and how do we incorporate that kind of session start event and tracking Windows authentication post that, this is a daunting challenge. And you're only going to have time to do this when there's an incident that's occurring. With Exabeam and our behavior analytics solution here, we're building these timelines and triggering these anomalous behaviors in real time for every user and every credential on the network every single day. So thank you, Randy. This is what I wanted to show on how we're able to leverage these domain controller authentication events and member servers to provide very good visibility and accuracy on when users are logged in and what they're accessing and how that relates to normal.
It's very awesome. I love it. And here's a question for you. We've got several for Exabeam. Is Exabeam a SIM, or do you enhance the data already in the SIM? How do you get the logs?
So we sell a security intelligence platform which is built 3 separate products. If you incorporate them together, that's our next-gen SIM. So we can either be the collection mechanism with our data lake, or you can slap our advanced analytics, what I just showed you here, on top of your existing data set. So if you have a SIM today, we can either integrate via APIs to pull the data from the SIM to our advanced analytics and give you these timelines and anomaly detections, or we can receive syslog from anywhere in the environment. That could be a SIM, or in some cases, a lot of organizations have log events that they can't pay to put in the SIM, and they may syslog directly to the analytics solution.
Okay, and Malcolm says, how well does Exabeam cope with laptops that regularly move around between sites or appear via, client VPNs and whatnot?
Yeah, so one of the things that Exabeam does is we build a baseline of behavior before we ever trigger an anomaly. And so even if machines move frequently, that's not an issue for Exabeam. We'll learn where those machines typically reside and what they authenticate off of. So I have a customer in the U.S. that's a railroad. And so each of the trains essentially has computers on them. And the folks working on the railroad are always taking those machines out of the train themselves into the different depots, and they're logging in from all different places. But we start to learn for like the peer group that, hey, these users always log in from these different places before we ever trigger an anomaly. So it's that baselining of behavior that allows us to kind of tune out the noise and give you that visibility of, hey, this is actually normal activity for these kinds of users or these assets. And then beyond that, one other thing I didn't touch on is Exabeam does offer entity analytics, which everything I showed you from a user perspective, we now do for entities. So we could actually model the behavior of that workstation or laptop itself.
I like that a lot. Does Exabeam, this is from Dennis, does Exabeam require agents per machine?
It does not require any agents. So on the analytics front, it's working purely off of log data. So you've either already collected that in your SIM, or you would use the Exabeam data lake to collect the data. Now, on the collection front, let's say you do decide to go with Exabeam's data lake and you do want workstation events, you may need to install an agent on there to get that data, or configure West and install an agent somewhere else. But the analytics itself does not require you to install agents everywhere across your environment.
Let's see here. Surinder says, how do you send event log data to Exabeam from Windows workstations and servers?
So typically, you would go through the process of sending it to a SIM solution first. So you would install the agent or install WEF and an agent on a WEF server, get that data centrally collected, and then forward it on via syslog, or let Exabeam fetch it from that SIM solution.
Brad asks, can you use these events to discover where and what device is causing an account to be locked out due to failed logins? Are you familiar with that problem in Windows, Andy?
Yeah, we actually built an entire feature around account lockouts, and we built this for a customer that basically said, we'll buy your product if you can solve this problem for us, because they had a full-time employee just triaging failed logins and lockouts. So we have a whole module looking at failed login and lockouts. We'll tell you things like each failed login, is it normal or abnormal? We'll call out the fact that users are failing to log into assets they've never successfully authenticated to. But we have a lot of security teams that are giving this portion of the product to their IT teams to help triage those failed logins and lockouts and understand where they're coming from.
Pamela asks, where is the data hosted?
So the source data is typically from a SIM solution, right? So that's either going to be on-prem or in the cloud. Exabeam is going to fetch a subset of that data to our appliance, which can be deployed on-prem physically. We can be deployed virtually on-prem, or we can deploy in your own private cloud, AWS, Azure, those kinds of things. So what we typically say is if you're going to deploy the Exabeam Advanced Analytics, we'd like to sit as close to your main log repository as possible. So if your SIM is in the cloud, we'll be in the cloud. If it's on-prem, we'd like to be on-prem as well. But as long as you can get data to Exabeam via syslog, it really doesn't matter where your source logs are or where Exabeam Analytics is.
Gotcha. So Ollie asks, with Exabeam, are you also able to detect threat injection, NetFlow activity, or system process anomalies on Barbara's system?
Yeah, so let's start first with the process execution. So I'm going to look at Sherry Lee here, and I'm going to actually turn on process execution endpoint activities. The NetFlow is a roadmap item. We just recently brought in the entity analytics, so as part of that, we will be supporting NetFlow in the near future. What we can see, though, if you want to look at process execution, we can stitch in process execution and even web activity into a timeline. So Sherry, again, starts a Kerberos login against her workstation, launches Chrome, accesses Facebook. But what we can do down here is in like the process execution, we can look at and model behavior. This is the first time we've ever seen this process execute for this peer group, as well as the first time it's executed for this user. So we can model which processes run for each user, even across the organization. We do this for things like services as well. We can look at, if we scroll down, this is actually an example of ransomware, where the user hits a domain generation algorithm, executes new processes, executes Tor, connects to a ransomware IP address. And then what's unique here is we're looking at file activity. So ransomware is going to read a whole bunch of files. It's then going to write the WannaCry file. It's going to write the new files, which are encrypted, and then it's going to delete all the files. And then we're also seeing process execution down here of processes that are doing things like disabling recovery mode and deleting shadow copies. So we can give you pretty early indication that ransomware is actually existing in your environment based purely on behaviors and not needing to know anything about, the signatures or threat intelligence feeds.
Okay, let's see here. Nand wants to know, is CASB, Cloud Access Security Broker, a feature with Exabeam? I don't think that's something that you guys get into. That's a very different type of product altogether.
So there's a couple things we can do. Is we can integrate with CASB solutions and take their logs to show you the activities users are performing within your cloud apps. We also allow, and we sell cloud connectors, which allow us to go in and just grab the logs via APIs and bring them to the analytics. So we can do things from a CASB perspective where we're showing you everything that's happening in the cloud apps and trigger anomalies, but we don't do the enforcement and the blocking that a CASB would do. So it's kind of CASB light if you want to get visibility into the activities that are being performed in your cloud apps. We do offer that.
Okay. Let's see here. Brian asks if does Exabeam play nice with OSIM, like open source SIM. I don't know, Brian, if you mean like a lot of people are trying to use Elastic as a SIM. It's not really. Is that what you're talking about, Brian? We'll hear back from him.
Okay.
Oh, it's OSIM. Okay. So let's see here. Next, let me see who we haven't gotten to yet. Okay, Justin says, does your product detect when syslog is out of sync, like for 3 days, and send an alert? So I think what he means, you can correct me if I'm wrong, Justin, what if you stop receiving events from an event source? Are we going to know about it?
Yeah, so we kind of tackled that challenge more on the data lake side versus on the analytics, right? My suggestion would be let's centralize that syslog along with the other events in a data lake in the Elastic, where we can have better health monitoring on the fact that, hey, this system is no longer sending data. We would do that on the data lake versus on the analytics. But the analytics does have health warnings. So if it does see a log feed that hasn't been reported for, I think it's up to like as low as 6 hours. Like I haven't seen any 4624s or VPN logins in 6 hours. You'll get a little health alert here to alert you to those log streams that might be down.
Got it. Let's see here. We have, I don't know, about 10 people asking about pricing, and that's usually something we don't get into in webinars, but what can folks do if that's what they are interested in finding out about? What's the next step that we should recommend?
You can reach out on our website, exabeam.com, and schedule a demo. I can tell you at a high level from a pricing perspective, it's based on number of employees in an organization.
Got it. Peter says, hey, in the earlier example, where does the process information come from, like that Chrome EXE ran?
So we can get it from a couple different places. We have customers that are deploying EDR solutions, and so this could come from a CrowdStrike. In some cases, you can install and configure Sysmon. We have a number of customers that are doing that, so a cheaper EDR, if you will. And in some cases, if you're collecting the workstation event codes, right, the Windows logs from local workstations, you do get process execution in Windows. It will log process execution as well as object access. So you can see process execution as well as file activity from the Windows event log.
Nice. Let's see here. Brad says, I tell you what, I'll let you handle Brad's question offline because it gets into some other companies and their products. I think we've tackled just about everybody's question. There's one here from Abby. If I usually VPN into the network from my laptop, how can I map IP address to my primary machine name using advanced analytics? So that's going to be a little bit different situation, right? Andy?
Yeah, so what Exabeam will do is it will look at the assigned IP or the source translated IP that's being assigned from the VPN concentrator, and then we'll tie that IP to the host. So we'll do the IP address association based on this event, and now we know Barbara Salazar is essentially operating from this IP. So this should then be the source IP of all other events we see from Barbara. And in some cases, VPN events can be tricky. I used to work with F5. And when you logged into the VPN, you got 3 different events. You had the user was successful, this is the source IP, and the third event would be the translated IP. And so Exabeam is actually doing the stitching of those events into one based on a session ID field itself. So we can take 3 different events, make it one, and show it here.
Okay. Let's see here. Abby says, but the VPN can keep changing every day, but yeah, you're looking at it for each session, right?
Correct, and even if the VPN drops and reconnects, we have a VPN relogin event, and that will also remap IPs and hosts if the IP that's being assigned is changed.
All right, cool. Let's see here. I think that's it. It's been a great session. I hope everybody found it valuable, and Andy, thank you for doing a really good demo that ties in directly to the stuff that we were talking about today. You guys have done an awesome job at being able to tell a story from all of this disparate log data.
Excellent. Well, thank you for having me. It's a topic near and dear to my heart because I know how painful it is trying to put these things together, and I believe Exabeam is a solution that can help pretty much every organization solve this challenge, even if it's just Windows event codes.
All right, folks, stay tuned. We'll be sending out a link to this recording, and we appreciate your time. Have a great day.